Hello, calculus teachers. My name is Tracy, and I'm a math teacher in residence at NumWorks. In this video, I'm going to introduce the NumWorks calculator and demonstrate how it can enhance your classroom experience. For those of you new to NumWorks, the NumWorks calculator was made by teachers for teachers. You can now spend less time troubleshooting and more time engaging with your students. In addition to the handheld calculator that is approved for all AP exams as well as the SAT and ACT, the NumWorks also provides a free online calculator and mobile apps. Not only are these great for classroom presentations, they also provide your students with a continuous access to the calculator. Today, I'll be using the online emulator, and I invite you to join me on your handheld calculator or by navigating to numworks.com/simulator. The NumWorks Graphing Calculator utilizes a familiar app-based interface. There are 4 apps relevant to the AP Calculus BC course. The Calculation app is great for calculating values in mathematical notation exactly like on your paper. The Grapher application, you can construct beautiful graphs in the perfect viewing window and easily find key points. It offers amazing visuals for derivatives and integrals. In the Equations application, you can solve any equation with the press of a button. In the Sequence application, you can explore convergence of series visually and numerically. In this video, we're going to first go through a few features of the NumWorks calculator that relate to the curriculum that is shared with AP Calculus AB. If you're interested in jumping straight to the BC topics, skip forward to the Parametric and Polar chapter of this video. Let's dig into these applications. The first application we're going to look at is our Grapher application. Let's press OK to open the application. The Grapher application is split into 3 tabs along the top: Expression, Graph, and Table. To plot a graph, we must first add an expression in the Expression tab. Click OK to add an element. You can start typing here right away, or you can go over and use a template to help you get started. Let's go over and press OK to use a template. And use the f of x equals x template to create a function. Let's edit this template to create the polynomial function f of x equals 2x cubed minus 5x squared minus 16x plus 15. Press OK to confirm your function. To view the graph of your function, navigate to the Graph tab and press OK. Right away, you can view the graph in a window that is automatically calculated based off of interesting points on the graph. You can also use your plus and minus key to zoom in and out of your graph. You can use your left and right arrows to move along the graph. As you navigate the graph, the cursor will snap to the black interest points, including maximums, y-intercepts, zeros, and minimums. You can also use your store arrow to store x values from this screen. For example, if I want to store the x value of the minimum, I can press the Shift key, followed by the x to the y key, and use my alpha keys to create the variable a. Let's start to look at some of the calculus visual tools we offer in the Grapher application. As a calculus teacher, you will frequently use your toolbox key. The toolbox key is located right below the OK key. This will house all of the calculus features that you need. Let's press the toolbox key now. This brings you to a Calculate menu on the f of x curve. The first calculus feature we're going to explore is in the Find menu. Navigate down and press OK. Here, you can find a lot of useful things to help students explore functions like x given y, extreme values, zeros, tangent lines, and integrals. Let's take a look at the Tangent Finder first. Press OK on the tangent. This screen allows you to turn your tracer into a tangent line. This is a great tool to help students build their understanding of slope. The bottom banner will also display everything you need to write both point slope form and intercept form of the tangent line. You can also use your number pad to jump to specific x values. For example, typing -2 and then pressing execute will give us all information for the tangent line when x is -2. Press OK or back to return to the graph and out of the Tangent Line Finder. Now that we have a great visual understanding of tangent lines, let's keep looking at some derivative visuals. We're going to press the toolbox key and this time head to the Options menu. The options have great features like color and plot restriction, but let's take a look at the derivative section. Here we have some important toggles. The value of the first derivative will add the values of f prime of x to the bottom banner as you trace the graph. Plot of the first derivative will create a graph of the first derivative as well as turn on the values of the first derivative. Note that there are second derivative options here as well, but we'll just look at the first derivative. Pressing the back key 3 times will get us back to the graph. Now we can see the graph of f prime of x. Notice how I traced the graph of f of x in the bottom banner displays f prime of x values. We can also explore how the maximum values of f of x correspond to the zeros of f prime of x. Let's explore the Table tab next. Navigate up and over to the Table tab and press OK. In the table of values, you can see columns x, f of x, and because we toggled on the derivative, we can also see f prime of x. By default, the table has x values 0 to 10. You can edit any of these values right away, or you can use the Set the Interval submenu to select a very specific table. The last thing that we're going to look at in the Grapher application is integrals with functions. Before we do this, let's add another function to our expression list. Navigate back to the Expression tab. Notice that f prime of x is an element in the Expression tab. Let's remove this by pressing the Delete button. Now we just have f of x graph. Let's add an element, use a template, and grab the g of x template. We'll edit this template to create g of x equals 3x minus 4. Press OK to confirm our graph. Now we can look at these graphs of these two functions in the Graph tab. To explore integrals, we need to press our toolbox key again and navigate to the Find menu. Down at the bottom, we have an integral, and because we've added a second function, we can also find the area between f and g. Let's choose the area between option by pressing OK. The bottom banner prompts us to select a lower bound. You can use your number pad to input a value or your left and right arrow keys to scroll. I want to find the area bounded between, so I'm going to use my arrow keys to scroll to the first intersection and press OK. Now, to select the upper bound, I'll use my right arrow key to scroll to my third intersection and press OK. Now we have the calculated area between f and g. The next application that we're going to explore is the calculation application. Press the Home key to navigate back to our home and over to Calculation app and press OK. Here you can perform a variety of computations. For many calculations, NumWorks will display multiple representations of a solution. For example, 1/2 plus 2/3 will display both 7/6 and the decimal approximation of 1.6667. The square root of 50 will show 5 root 2 and the decimal approximation of 7.07. Sine of pi over 3 will display root 3 over 2 and its decimal approximation as well. Some calculations even have additional results available. Just navigate up into your history and over to the 3 dots. Here you can see the additional results. Like for trig, you can see the value displayed on the unit circle, and down below you have the sine, cosine, and tangent values. I'll back out of my additional results now. You can also do computations with stored functions. For example, if I want to find the average rate of change of f of x from 1 to 5, I can start by pressing the division key twice to create an empty fraction template. Then I can press the var key to access my stored function f of x. Then I can input f of 5 minus f of 1 over 5 minus 1. Press execute to see your computation. Now let's look how to compute a derivative at a point. Remember, the toolbox key is very important for calculus. Let's press the toolbox key to access all operations that don't have their own button. Here you can find advanced operations like the absolute value, the nth root, and log base a. From there, advanced operations fall into categories. You can access all calculus operations within the calculus section by pressing OK. First, let's look at our derivative options. You can evaluate a derivative or an nth derivative. Let's first compute a derivative by pressing OK. Start by inputting the expression you want to find the derivative of using your x and t key. Let's compute the derivative of x squared minus 5x at x equals 2. Now, to compute a higher order derivative, you can either edit an existing derivative or use the template from the toolbox. Let's go up into our history and press OK on the derivative we just computed. This brings the expression to the input field. You can navigate now to the d dx, component and add an exponent in the numerator or denominator. Let's use the square key to change this to a second derivative and press execute. You can also compute an nth derivative using the operation in the toolbox. Let's press the toolbox key again. Note that we're still in the calculus menu. Press OK on the nth derivative. Here, you need to input your expression, derivative level, and the x value. Let's compute the third derivative of cosine of x at x equals pi over 2. The last way to compute a derivative is using the prime notation on a given function. Let's grab the f of x function again from our var key and navigate to in front of the parentheses. To add the prime, we'll use the alpha key followed by the toolbox key to access a single prime mark. Then navigate to the right of the parentheses and input your x value, for example 5, and press OK or execute. This computes the first derivative of f of x at 5. You can also use the alpha toolbox key to add additional prime marks if you would like to compute higher order derivatives using this notation. The last calculation you will need to know how to compute is an integral. This calculation can be accessed again from your toolbox. Press the toolbox key and navigate to the integral option and press OK. For this computation, you need to input your bounds and integrand. Let's compute the integral from -5 to 7 on the arctangent of x. To access the inverse trig, use the shift key followed by the tangent key. If we want to instead find the total area, you can quickly change this integral by navigating up and pressing OK to re-grab the integral. Navigate to the beginning of the function. Press the toolbox key to access your advanced operations and back out of the calculus menu and press OK on the absolute value. Notice that the absolute value covers the entire arctangent of x function. Now press OK. The next application we will explore is the equation application. Press the home key and navigate to the equations application and press OK to open up the app. Within the application, you can use your keys to start typing equations right away. For example, we can solve the equation x cubed minus 5x plus 4 equals 0. To access the equal sign, use your shift key followed by the pi key. Confirm your equation and navigate down to Solve the Equation button and press OK to see the solutions. You can also solve derivative and integral equations using the equation solver as well. Let's go back and delete the first equation. Let's find where the second derivative of x is equal to 0. To do this, use the var key to grab your f of x function, navigate before the parentheses, and press the alpha toolbox key twice. Navigate before the parentheses and input the variable x. Now, at the back of our second derivative, we're going to use the shift pi key to input equals and then 0. Press the OK or execute to confirm your equation and then go down to solve the equation and press OK. Here, you can see the values that make the second derivative of f of x equal to 0. Now that we've taken a look at all of our A-B topics, let's take a look at our BC only topics. To start, we're going to explore how the NumWorks graphing calculator can work with parametric and polar functions. Let's go back to our grapher application and delete our existing expressions. Let's begin by inputting a parametric function. Press OK to add an element. We're going to use a template and navigate down to the parametric template. Press OK to edit this template. Let's edit this template by changing the x component to 1/2 t squared. Within the parametric template, the x and t key will default to t. Now we have the parametric function f of t equals 1/2 t squared, comma, sine of t. Now that our function is inputted, let's take a look at the graph. I'm going to quickly turn on my auto zoom by navigating up and pressing OK on auto. Here, you can trace your parametric functions for different values of t. You can also use your number pad to input values of t to jump to those values. For example, let's input 2 for t. Let's take a look at some of the calculus features we have for parametric functions in the grapher. Press on the toolbox key to access their advanced functions. Let's start in the Find menu. Here, you can find dy dx, which is the slope of the tangent line, or you can find the full tangent line equation. Let's look at the full tangent line by pressing OK. Similar to how the tangent line works for functions, this tracer creates a visual for a tangent line. The bottom banner will give you everything you need to create the equation of the tangent line in both point-slope form and slope-intercept form. Let's press the back key to return to the grapher, and let's press the toolbox key again. This time, let's explore the calculus options in the options menu. Here you can go into the derivatives and toggle on the first and second derivative values. Going back, the option menu is also how you can change the t-interval that is graphed in the plot restriction. By default, the parametric functions are graphed from 0 to 2 pi. I'll leave the plot restriction as default, but let's back out and see how the graph will work now that the derivatives have been toggled on. Now, as we trace the graph, the bottom banner will display the ordered pairs for the first derivative and the second derivative. Toggling on the derivative value will also add columns of these values in the table as well. All of these fine features and options are also available for polar functions as well. We won't go through all of them again, but let's add a polar function to our expression list to see what the graph looks like. Back in the Expression tab, let's press OK on Add an Element and use a template and scroll all the way down to Polar. We'll use this polar template to create the rows r1 of theta equals cosine of 2 theta. Now that we have our polar function created, let's look at the graph. Let's navigate up and reactivate our auto window. Now that we have a polar function created, on the graph you can use your up and down arrows to move the tracer between the parametric and the polar. As you trace, you can see the theta values and r values. In the toolbox, you can access the same Find menu and options that were available for parametric function. The Find will contain dy dx and the tangent line. The options will provide you the option to toggle on derivative values and change the plot restriction. Now that we have a parametric and polar function stored into the calculator, let's navigate to the calculation application and see how we can use these functions to compute derivatives and integrals there. Before I begin, let's clear out the work that I've done before. To clear your calculation history, simply press Shift, Delete. Now, for example, if we want to compute the first derivative of f of t when t is pi, we can use the variable key to grab the function f of t, use the alpha key to input our prime, and then pi to obtain f prime of pi. You can also evaluate the x and the y parametric equations separately. For example, if I wanted to compute dy dx of the parametric equation, you can use your var key and the alpha toolbox key to find fy prime of pi over fx prime of pi. You can also use the stored functions to compute integrals as well. For example, let's find the area of the polar curve. To compute the area, we'll use the formula 1/2 times the integral of r squared. Use the toolbox key and go into the calculus operations to grab the integral. We'll use the bounds 0 to 2 pi, and then for the integrand, we need to grab r1 using our var key. Input the argument to match the term of the integral. In this case, we'll use x, and then square the function. If you want to change the variable so that the integral is computed in terms of theta, which will most likely be the variable students will write on their paper, you can change the term of the index by editing the dx part of the integral. Let's go up and copy the integral from above. Use the left arrow to navigate to the dx. Delete the x and then use the x and t toggle to access theta. Now we must change the argument of the function to match the term of the integral. Navigate to delete the x. The x and t key will now default to theta to match the integral so that we can press this once to access theta. Press OK to calculate the area. The last thing that we'll look at for BC topics is our support of series and power series. Navigate to the home screen and start in our sequence application by pressing OK. In this application, we can explore sequence and series convergence behavior. For example, let's add the geometric sequence 1 over 2 to the n power. We'll use our x and t key to access n within the sequence application. Press OK to confirm the sequence. You can explore this sequence in graph form or numerical form. We can notice that as n approaches infinity, the values of the sequence are approaching 0. Now let's look at the sequence of partial sums. Navigate back to the Sequence tab, and we're going to add another sequence using the Toolbox key. Within the Calculus section of the Toolbox key, we can grab our sum operation. Let's start the sum from 1 to n. The x and t key here will default to n. Then use the var key to grab the u sequence that we defined above, and do u sub k using the x and t key. Press OK to confirm our sequence. Now we can explore both the geometric sequence and series as n approaches infinity. We can see in the table of values that while the sequence is converging to 0, the series is converging to 1. We can also see what this looks like in a graphical representation as well. Lastly, in the Grapher application, we can explore graphs of power series. Let's navigate to the Graph application and clear out our existing expressions. Let's add the graph of e to the x and the power series that converges to this function. To add a power series, press the Toolbox key, and within the Calculus section, grab a series. Set the lower bound to 0 and the upper bound so that we can see a partial sum Taylor polynomial. I'll first start with the upper bound of 3. Then we need to input our power sequence. Within this series, the x and t button will behave as the k variable, so we'll have to use alpha 2 to grab x. Raised to the k power, using the x and t key, all over k factorial. You can access the factorial by using the alpha decimal point. Now we can observe the graph of these two expressions. I'll use my minus key to zoom out a little bit, and my up and down arrows to explore the graph of these two expressions. Notice that how the graph converges around 0, but quickly diverges the further from 0 you get. If we could do an infinite sum, we would see that the series converges absolutely. We can edit the expression to increase the number of terms in the polynomial to see if the radius of convergence increases. For example, let's set the upper bound to 10. Now we can see that the Taylor polynomial converges for a larger radius when the upper bound of the series has been increased. I can zoom out to see where it can start to diverge, and up and down to switch between the expressions. I hope this video demonstrates to you some of the many ways that NumWorks Calculator is the perfect calculator for AP Calculus. If you're a high school math teacher, you can request a free sample calculator. Simply head to num.works/community to claim your free calculator now. Thank you for watching. If you have any questions, please don't hesitate to contact us at contact@numworks.com.